What's up, 8th grade? This video is for homework 8-4, comparing linear functions. So we're going to be comparing two things and looking at their initial values and their rates of change and deciding, hey, which one has a greater or lesser initial value and which one has a greater or lesser rate of change. So number one says, which linear function has the greater rate of change? The one described by the equation, and they give us an equation, or the one described by the table. So the key here is they're giving us information, but the information is speaking two different languages. We have this equation, and so this is speaking equation, I'll just call it. I'm going to rewrite it so that it's a little bigger. Y equals 2x plus 1. And then we have a table over here, right? So the equation's easy. We know that equations are written in y equals mx plus b form. And so if I want to find the rate of change of this equation, I just look at the number being multiplied by the variable, right? We know that our rate of change, also known as our slope, in this case is 2. The table is a little different. We actually have to go ahead and calculate the rate of change of this table. And the way we do that is, well, remember that the x-coordinates measure our horizontal movement, also known as the run. Right? If we move to the right, that is our run. And the y-coordinates measure how much we go up or down, also known as the rise. So if I'm going to write the rate of change for this table over here, I need to put the rise over the run. So let's go ahead and start with the x-coordinates here. Notice that they're increasing by 1 every time. I go from 1 to 2. I went up 1. I go from 2 to 3. I went up 1. I go from 3 to 4. I went up 1. So my run is 1. Right? This is how much I'm moving to the right every time. Well, how much am I going up or down, right? If the numbers were decreasing, right, we would have a negative rise because they're going down. But in this case, they're going up. Well, by how much? I went from 6 to 13, so that's, I added 7. I went from 13 to 20, I added 7, and 20 to 27, I added 7. So again, if I was going to make a slope triangle that represented this, right, I would have an arrow that went up 7, and I would have a shorter arrow that went to the right 1. And we would end up, or our line looks something like this. All right, so the table has a rate of change of 7 over 1, which is just 7, and now we can compare the two. The question is, which has the greater rate of change? Obviously, the table does. The function for the table has the greater rate of change. Got it. Okay, remember, you can always pause, rewind, and watch this problem again. There are several problems on this assignment that involve tables. All right, the next question I'm going to do is number 4. And number 4, we're talking about the temperature on 2 different days. So Monday and Tuesday. And we start measuring at 7 p.m., right? We take the temperature at 7 p.m. on both days, and then we're going to see what happens between 7 p.m. and midnight. Now, right away, you should start thinking, well, wait a minute. The sun has gone down, right? So it's going to get colder, right? Think about, if you went outside at 7 p.m., and then you went outside again at midnight, it's obviously going to be colder at midnight because the sun has been down for longer. The sun is now on the opposite side of the world, right? So we're going to have some starting value, and then our temperature is going to decrease. So let's see. We're talking about Tuesday and Wednesday here. On Tuesday, so I'm going to go ahead and write Tuesday here. Tuesday, the temperature, and they want us to use T for temperature. So the temperature is equal to, let's see, at 7 p.m. it was 41 degrees. Okay, so we start off at 41, and then it dropped. Dropped means it went down 2 degrees each hour. All right, and they want us to use H for the number of hours. So the temperature was 41 degrees, and then it went down 2 degrees each hour. So now I have a nice equation that represents what happened on Tuesday. The temperature is 41 degrees, right, minus 2 degrees every hour after 7 o'clock. All right, let's take a look at Wednesday. Now, Wednesday is easy because they actually give us the equation, right? It says the temperature on Wednesday is equal to 47 degrees minus 3 degrees every hour. And then let's get to the actual question. What do the initial values? Well, remember like I said in class, the initial value is your first measurement. It's like, hey, if I was going to start measuring you today, right, we would take you're 5 feet tall today. That's your initial value, right? And then we'll measure you every January for the next 10 years and see how you grow. So for this problem, we started measuring at 7 p.m. So our initial value would be the temperature at 7 p.m. So for Tuesday, my initial value was 41 degrees. That's where we started. And then the temperature went down 2 degrees every hour. So there's our initial value. And on Wednesday, the temperature was 47 degrees at 7 p.m. when we started measuring, right? And then it went down 3 degrees every hour. So the temperature tells us, hey, this was the temperature at 7 p.m. when we started measuring. So which of these is correct? The temperature was less at midnight than it was at 7 p.m. for both days. That is true. Okay, this is absolutely true, but it doesn't answer the question. Obviously, the temperature is going to be less at midnight because the temperatures are decreasing, but that's not what the initial value tells us, right? So that can be kind of tricky. Remember, you always want to make sure you're answering the question. What do the initial values tell us? The temperature at midnight was less on Wednesday than on Tuesday. Again, we could figure that out using these equations, but that's not what the initial value tells us, right? Don't overthink this question. The temperature at 7 p.m. was less on Tuesday than on Wednesday. So remember, 7 p.m., that's our first measurement. It was less on Tuesday than it was on Wednesday. There's our winner chicken dinner. The temperature changed faster on Tuesday than on Wednesday. That's actually not true. The temperature is changing 2 degrees every hour on Tuesday, 3 degrees every hour on Wednesday. So it's actually going faster here. So again, D is also true, but it doesn't answer the question. It doesn't answer what do the initial values tell you. So our correct answer for this one, the temperature at 7 p.m. was less on Tuesday than on Wednesday. So really what this assignment is doing is actually forcing us to apply these mathematical concepts that we've learned, right? We actually have to use them now. And that can always be a difficult leap to make for a lot of kids. So make sure you're asking questions in class. All right, got one more question to go over. Again, at any point, you can always pause and rewatch a problem. All right, question 6 has to do with burning candles. Before I even read the question, let's just review what happens to a candle, right? So a candle is brand new, right? There is my candle. It is brand new. And then I go ahead and I light it, okay? And then I check on it 5 hours later, and my candle now looks like this, all right? It got shorter, and I'll probably have a little puddle of wax around it, right? And it drips wax. So a candle starts off at one height, and then it's going to get smaller. It's going to decrease, right? So we're going to start off tall, and our candle is going to get smaller, and eventually our candle will just be a little puddle on the ground, right? We would reach all the way to the ground. All right, a linear function models the height of a burning candle. Candle A comes out of the mold at 219 millimeters. So they just gave you the initial value, right? The mold is where you actually make the candle. So we know that candle A starts at 219 millimeters. and is expected to be 195 millimeters after 4 hours. So you can see that it got smaller, right? We went from 219 to 195, and it took 4 hours to do that. More on that in a little bit. The model for candle B, so we have an equation here for candle B, is the height, right? So our height is h, is equal to 300 minus, it looks like this would be 5 millimeters. Where h is the height in millimeters and t is the time in hours. So this candle starts off at 300. So we have to be fluent in math here. We have to recognize that, hey, this candle is starting off at 300, and then it's going to lose 5 millimeters every hour. What are the initial values of each candle, and what do the initial values for each candle tell you? So that's why, again, the question here has to do with initial values more than it does the rate of change, and that's why I'm focusing on the 300 and the 219. So the initial value for candle A, well, that's the height that it was coming out of the mold, so that'd be 219. The initial value for candle B, that's going to be the 300, right? It starts off at 300, and then it loses 5 millimeters every hour. And what do the initial values tell you? All right, I'm going to erase this real quick. The height for candle A and candle B are the same. That's not true, right? One is 219, one is 300. Candle B is taller than candle A when they begin. Yep. Right? 300 is definitely taller than 219. Candle A will burn faster. That has to do with the rate of change, right? That's not an initial value question. That's a rate of change question. It may or may not be true, but again, it has nothing to do with the initial value. Candle A is taller than candle B. This does have to do with initial value, but candle A is definitely, right, here's candle A, definitely not taller than candle B. So what the initial value tells us in this situation is that candle B is taller when they begin burning. Okay, again, this video is meant just to get you started. It's not meant to be a complete lesson where you're going to be able to answer every single question. I chose 3 different types of questions. So if you need to go back, rewatch any one of these 3, definitely do it. Make sure you're asking questions in class. And I will see you guys soon.